Hey, welcome back. In this lecture, we're going to learn our first architectural pattern, the multi-tier architecture. We will first get a general introduction to this pattern, and later we will proceed to learn about some of the most common variations of this pattern. Most importantly, by the end of the lecture, we will know when to apply this pattern to our system and when to seek other solutions. So let's start with a general introduction to the multi-tier architectural pattern. The multi-tier architecture organizes our system into multiple physical and logical tiers. The logical separation limits the scope of responsibility on each tier, and the physical separation allows each tier to be deployed, upgraded, and scaled separately by different teams. It's important to point out that although occasionally you may hear people using the terms multi-tier and multi-layer architecture interchangeably, they are in fact two different concepts. Multi-layered architecture usually refers to the internal separation inside a single application into multiple logical layers or modules. However, even if the application is logically separated into multiple layers, at runtime it will run as a single unit and will be considered as a single tier. When we talk about multi-tier architecture, we mean that the applications in each tier physically run on different infrastructure. Besides the benefits of logical and physical separation that allows us to develop, update, and scale each tier independently, there are a few restrictions in this architectural pattern that simplify the design. The first restriction is that each pair of applications that belong to adjacent tiers communicate with each other using the client-server model, which is a perfect model for RESTful APIs, for example. The second restriction discourages communication that skips through tiers. This restriction keeps the tiers loosely coupled with each other, which again allows us to easily make changes to each tier without affecting the entire system. So now that we got an introduction to the multi-tier architectural pattern, let's talk about one of the most common multi-tier architectural variations, which is the three-tier architecture. The three-tier architecture, to this day, is one of the most common and popular architectural patterns for client-server web-based services. In the three-tier architecture, the top-level tier contains the user interface and is often referred to as the presentation tier. The responsibility of the presentation tier is to display information to the user and also take the user's input through a graphical user interface. Examples of the presentation tier include a web page that runs on the client's browser, a mobile app that interacts with the user on a mobile device, or a desktop GUI application. The presentation tier normally does not contain any business logic for many reasons. One of those reasons that applies specifically to code that runs in the client's browser is that this code is directly accessible and visible to the user. Since generally we don't want the user to see and potentially change our business rules, it is an anti-pattern to include any business-specific logic in the presentation tier in general. The second middle tier is called the application tier, or sometimes also referred to as the business tier or the logic tier. The application tier is the tier that provides all the functionality and features that we gathered from our functional requirements. This tier is responsible for processing the data that comes from the presentation tier and applying the relevant business logic to it. The last tier is the data tier. This tier is responsible for storage and persistence of user and business-specific data. This tier may include files on our file system, and most commonly it includes a database. So what makes the three-tier architecture such a popular choice? One of the reasons that the three-tier architecture is so popular is because it fits a large variety of use cases. Almost any web-based service fits this model, be it an online store, a news website, or even a video or audio streaming service. It's also pretty easy to scale horizontally to take large traffic and handle a lot of data, and let's see how. The presentation tier, of course, does not need any special scaling, because it simply runs on the user's devices, so it essentially scales by itself. If we keep the application tier stateless, like we should when we use something like a REST API, we can then easily place the application tier instances behind a load balancer and run as many instances as we need. And finally, the database can also be scaled very easily if we use a well-established distributed database, which we can scale by using the techniques that we already learned, such as replication and partitioning. Finally, this architectural style is very easy to maintain and develop because all the logic is concentrated in one place, in the application tier, where all the backend development actually happens. And we don't need to worry about the integration of multiple codebases, services, or projects. So when does the three-tier architecture stop working for us? Well, the three-tier architecture has one major drawback, which is exactly the reason why it's so popular and easy to apply. This drawback is the monolithic structure of our logic tier. Since, as we mentioned earlier, we do not want to have any business logic in the presentation tier, and of course, we can't have any logic at all in the data tier, we are in a situation where all our business logic is concentrated in a single codebase that runs as a single runtime unit. That has two implications. The first implication of this drawback is that each of our application instances simply becomes too CPU intensive and starts consuming too much memory. This makes our application slower and less responsive, especially with memory-managed languages like Java or C#, which as a result will have much longer and more frequent garbage collections. All those issues may require us to start upgrading each computer we run our application on, and we already know that vertical scaling is both expensive and limited. The second implication of the monolithic nature of the application tier is low development velocity. As our codebase becomes larger and more complex, it gets much harder to develop, maintain, and reason about. And hiring more developers will not add too much value, because more concurrent development will simply cause more merge conflicts and higher overhead. We could somewhat mitigate this problem by logically splitting the application's codebase into separate modules. However, those modules will still be somewhat tightly coupled, because we can release new versions of those modules only when the entire application is upgraded. So, in other words, the organizational scalability of the three-tier architecture is somewhat limited. So, in conclusion, the three-tier architecture is the perfect choice for companies whose codebase is relatively small and not too complex. And also, it's maintained by a relatively small team of developers. This includes early-stage startup companies, as well as well-established companies that fit those criteria in terms of the size of the codebase and the organization. In addition to the three-tier architecture, there are a few other variations to the multi-tier architectural pattern, so let's take a look at a few of them. Besides the obvious one-tier architecture, which is simply a standalone application, we have the two-tier architectural pattern, which is maybe less common than the three-tier architecture, but is still pretty popular. In the two-tier architecture, the top-level tier includes both the presentation and the business logic, and usually runs as a feature-rich mobile or desktop application. The second tier is the data tier, which, just like before, takes care of the storage and persistence of the users and business data. The two-tier architecture eliminates the overhead of the middle logic tier and usually provides a faster and more native experience to the users. A few examples of the two-tier architecture use cases include desktop or mobile versions of a document, image, or music editor that provides all the functionality and the graphical interface on the user's device, while all the storage and backup takes place on a remote server that belongs to the company that provides this application. On the other end of the spectrum, we can have a fourth tier in between the presentation tier and the business tier, which separates some of the functionality that doesn't belong in either of those tiers. For example, if we support multiple client applications in the presentation tier that have different APIs to us or have different data and performance requirements, we can introduce something like an API gateway tier that can take care of security, API, and format translation, as well as caching. Having more than 4 tiers is extremely rare, because more tiers normally do not provide much value and simply adds additional performance overhead. This overhead comes from the restriction against bypassing tiers, which otherwise would lead to tight coupling. So now every request from the client has to pass through multiple services, which can increase the response time for the user. However, we rarely need to pass every request through so many services. So in the following lectures, we will look at other and better options of organizing our system if we need to split our codebase into multiple components. In this lecture, we'll learn about the first architectural pattern, the multi-tier architecture. We learned about its general structure, which splits our system architecture into multiple logical and physical tiers, which allows us to develop, upgrade, and scale each tier completely independently. After that, we talked about the most common variation of the multi-tier architecture, which is the three-tier architecture. More importantly, we talked about the use cases, the scale, and the complexity of the codebase that best fits this architectural model, and when we should consider other alternatives. And finally, we concluded with a few other variations of the multi-tier architecture, the two-tier architecture and the four-tier architectures, which are also very common. I'll see you soon in the next lecture.